Okay, good afternoon. It's 5 p.m. Yeah. So today we're learning the section 3B. Before I talk about the lecture notes, first of all, I want to double check with you. Everybody sees the lecture notes, Unit 3B in the canvas already, right? Give me some emoji or nod your head if you have saw that already. Section 3B. Okay, great. Okay, so the second announcement, I send some of you an email. If you have a significant missing of the homework or discussion, I send you a notification email already. So if you have not replied to my email, please reply to my email or feel free to talk with me after this class. Okay, it's very important. If I don't hear from you, I will keep sending you emails until you reply to my emails or talk with me. Okay, so any question before we start section 3B? Let's get started. So this section, we are learning how to deal with very large numbers and very small numbers. As you can see, the first number is extremely large. It's 670 blah 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 blah, so many zero. And the second number is extremely small. So when we write, we don't want to write such a long number. Instead, we have a so-called scientific notation. Scientific notation is a way to make those long strings short. Okay. Let me write this sentence down. The easy way to make long strings short. We have those big numbers and we have scientific notations, which is significantly shorter. Then the major task today is learn how to convert a number from ordinary notation to scientific notation. First, we should move the decimal point to come after the first non-zero digit. For the first number, which is here, the first non-zero digit is 6. So we try to move the decimal places to here. However, when we move it, we're not just move it arbitrarily. We should multiply something 10 to some power. Okay, so then the second step is determine multiply with 10 to what power? It's determine 10 to which power? So here it says very clearly, for the power of 10, use a number of places the decimal point moves. Okay, we have two scenarios. Sometimes we are very big. Sometimes we have a very small number. For big numbers, you are moving the decimal places. Originally it's here, since it's moving to the left. You are multiplied with a positive power or just a positive number. In this case, it's 9. It's a positive 9. Sometimes we have a very small number, 0, blah, 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 2. So originally the decimal is here. Now you're moving right. move right. So in this case, you should multiply with the negative power, just like here is negative 15. So how do we get this 15? Because this is how many times we move the decimal places. Okay, from here to here. Okay, so any question why we use a scientific notation and why we use 10 to some power, 10 to the negative power, that kind of stuff? Any question about my explanation here? Feel free to ask if you have any question. Okay, so let's get started. Those explanations, they are very abstract. Let's put into a exact example to see how we can handle it. The first example is 5769. We want to express the scientific notation when we should move the decimal places. Remember that there is a default place for the decimal. It is defaulted here, okay? Originally, it is default here. Now you want to move to the first non-zero digit. Come after the first non-zero digit. So you move one place, second place, 3 places, which give you 5.769. Okay, once you move it 3 times, and do not forget you also have 10 to the power. So we move the decimal place 3 times. Look at my pen, 3 times. So we should have to the power of 3. Okay, so any question on this point? Okay. So I will do example A and C, and I'll give you, let's say, 2 minutes to figure out B and D. So A and B, they are big numbers. So if I do A, exactly the same process you should use to do B. C is a very small number. If I do C, exactly the same process you will do with D. Okay. So look at example 3. Decimal places here. You want to move the first non-zero digit, which is 1, little bit to the right of 1. So move 1, 2. So move it twice. So which give you 1.24, and do not forget that this is a very small number, okay? And you move it twice. So you have a negative power. Okay. So let me pick a number, positive power, small number, negative power. Okay, so just help you memorize it. So now I'm done with A and C. Does anyone has any question about A and C? Cool. So if nobody has any question, I just give you 2 minutes to work on your own. B and D. Okay, so 2 minutes is over. Let's look at the first one. We repeat almost exactly the same process as A. Originally, there's a default decimal place with here. Now you move 1 unit to the right, second unit, third unit, fourth unit, fifth, 6 times. Okay, so now you know it's 10 to the 6th power. Okay. Anyone has any question about this? How about D? The decimal place is here, and this is a very small number. So you could imagine we need some negative power. So let's see how many times we need to move the decimal point. From here to here, 1, 2, 3, 4, 5. Great, so move 5 times. Which gives us -5. That's it. Does anyone has any question about ABCD? Signs are good. So once we convert from ordinary number to scientific notation, we also want to go back. Just like if you go to any place for a trip, let's say you travel to Hawaii, you always book a round trip, not book a one-way trip, right? You don't want to go there and unable to come back. Once you finish such a conversion, you also want a way to come back. Since you don't want to stay on that island for your entire life. So how do we convert? To convert a number from scientific notation to ordinary notation, the power of 10 indicates how many places to move the decimal point we just did. So this is just repeat the idea what we just did. And now, if it is positive, we should move the decimal place to the right. So let's focus on in this case. If you want to convert it back, so the decimal places have to move right. Here, here, here. Okay, look at my pen. Here, here, here. So that's how you go back. If it has a negative power, then move to the left. Look at this case. So the decimal places should go back, 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 back. That kind of moving left. Okay, since it was originally far left to the 5. So we're just, since we moved to the right, when we go back, we should move to the left. So everything is just symmetric. And how many times you move the decimal places, fill them all with zeros. Previously, we tried to get rid of so many zeros by using the power. Now we should create the zeros again. Okay, any question about my explanation about this part? So let's do examples. Again, I'm going to do A and leave B as your exercise for yourself. I'm going to do C, but leave D as an exercise for yourself. You have 4, and always think there's a default decimal places. decimal point here. So originally you have 4 decimal point here. Now you should move 1 place since you have 3 times. So move it 3 times. 1, 2, 3. Okay. So 4 points, there are 3 times because the first is the default decimal point. If you go here, that's your first move. If you go here, second move. If you arrive at the final point, that's the third move. So if you fill all the places with 0, so 1 0 here, 1 0 here, 1 0 here. So give you 3 zeros. Okay. So anyone has any question on this question? Look at the question C. This time you have a negative power. So which means you should have some very small number. So originally the decimal place is here, and now you see the power is negative 4. So you move the decimal place 4 times. The first time, second time, third time, fourth time, okay? Then fill all the places with 0. So the first decimal place is here, point. So it's 0.009. Or if you prefer, you can also add a 0 in front of the decimal point. They mean exactly the same thing. If you would prefer, you can put a 0 here. Okay. So anyone has any question? Okay. Signs are easy. So I'll give you 2 minutes to work on the B and D. Okay. So before I start, does anyone has any question about A and C? So quiet. So let's just follow the rules to do question B. So you see 7.2, that's the decimal places. And we have 8, positive 8. So we are moving to the right. So moving to right 8 times. So first time, second time, third time, fourth time, fifth time, sixth time, seventh time, eighth time. So you have 7.2, 0, 0, 0, 0. Put all the zeros in the space. Then it looks very messy since you have so many decimal places. We should erase our trace. Erase our trace in doing such a work. So all the decimal places are unnecessary right now. So you just remove all the decimal point. So things would look nicer. That's it. Anyone has any question? Very similar with C. The question D, you follow the exact same process. You first realize you have a negative power. So you should move the decimal place to the left. So you copy the number again. Then you start moving this decimal point. How many times? 7 times. So first time, second, third, fourth, fifth, sixth, 7. Now put all the zeros between the spaces. Now, only this decimal place is meaningful because we are denoting a very small number. All the decimal places, all the traces of our movement should be erased. So let's recopy the answer. That's it. If you would prefer, you can put a 0 here, but it does not make any difference. That's it. Anyone has any question? Okay. So let's look at how do we do multiplication if we write numbers in the scientific notation. So here's the example. We multiply something 5 to the 10 to the third power times 4 to the 10 to the fifth power. You are multiply with 5 with 4, then times 10 to the 3 times 10 to the 3. So 5 times 4 give you 20, 10 to the 3 plus times 10 to the 5. So when you multiply 2 powers, you're just adding them together. 3 plus 5. You're just adding them together. So now you have 10 to the 3 plus 5, which is 10 to the 8. First, 20 still there, 10 to the 8. What is 20? 20 is just 2 times 10 to the 1. So this becomes 2 times 10 to the 1 times 10 to the 8. So when you multiply, it's just 2 is still there. 10 to the 1 times 10 to the 8 give you 10 to the 9. That's it. So this is an illustrative example. We should do the practice 3. And I will do it A first, and I will leave you to do the B. Do not be scared by the negative powers. We are following exactly the same process as here. Just adding the powers. Even if they are negative, they can still be added. So -3 add -9 give you -12. Okay, so I will do A, and I'll give you, let's say, 2 minutes to do B. So just repeat the same process. This number times this number. First separate those without powers. So 3 times 7. Then try to combine those with powers. 10 to the 8, 10 to the -2. 10 to the 8, 10 to the -2. So once you do such thing, this is just 21. Power adding. So 10 to the 8 minus 2. 8 minus 2. 21 times 10 to the 6. What is 21? What is 21? Why this number is so special? Does anyone has any opinion? This is not mathematics. I'm just trying to make some jokes. What is 21? Okay. Sajvala says it's prime. Well, it can be broken into 7 times 3, so it's not a prime. But thank you for trying. So this is not a mathematics. This is just trying to make our classes fun, since we have plenty of time in lecture. So what is 21? I see somebody is laughing. Queen, you're laughing. Sure, what are you thinking?
I was just laughing at Louise's 9 plus 10 comment.
Okay, so, okay, got you. So, and 21 is not 9 plus 10. So, so I think you guys should be very sensitive to this number, because that's a legal age for you to drink, right? So, oh, Kiddist is right on the age of 21. And there's also a clothes brand, this kind of clothes brand, which is called Forever 21, right? So yeah, it's if you're in 21, so you should enjoy the time. I passed 21 long time ago, so I miss the good olden days. That's why I'm talking about 21, and remind you, you should value you're 21 years old if you are. Okay, so much talking. So go back to this mathematics, 21. So 21 is not a small number. We should try to make it small. So we have to make it 2.1 times 10. But do not forget, we also have a 10 to the 6 here. So this is 10 is just 10 to the 1. So 2.1 times 10 to the 1 plus 6, 10 to the 7. That's it. Okay, does anyone has any question on this one? Okay, I think I can give you, let's say, 2 minutes to do B. Okay, feel free to ask me any question. Okay, 2 minutes is over. Let's come back to the B. Again, as our tradition, we move all the similar numbers together. So 5, 6, they're simple numbers. 10 to the negative 3 power, 10 to the negative 9 power, they're complex numbers. So you should move the powers together, simple numbers together. So 5 times 9 times 10 to the negative 3 times 10 to the negative 9. So what would you get? 5, 9, 45. 10 to the negative 3, 10 to the negative 9. So you are adding negative 3, negative 9 together. So 4, 5 times 10 to the negative 12. And 45 is 4.5 times 10 to the 1, right? Times 10 to the negative 12. Then you're adding those numbers together, 1, negative 12. So 4.5 times 10 to the 1 minus 12. And you can cancel those similar items. 10 to the 1 minus 12 is negative 11. That's it. So does anyone has any question on this one? So, okay, once we finish multiplication, we will do division. Just like what we did in the elementary school. We learn plus, then we learn minus. Then we learn how to do multiplication. Then we learn how to do the division. So let's look at this case. Here we have an example. What should we do when we do such a division? The idea is exactly the same with multiplication. Similar small numbers divided with small numbers. Those powers, they are grouped together to do the chemical reaction. So this guy can have the reaction with this guy. So 2.1 divided by 8.4. 2.1 divided by 8.4 here is 0.025. And the power divided by 10 to the 7. Here's the trick is, since you're doing division, you're doing here, I just noticed that there's a bug here. Apologize for that. So here you're doing division. So 10 to the 3 divided by 10 to the positive power 7. So when you divide it to the 10 to the positive power 7, this positive power turned out to be a negative power. So divided by 10 to the positive power 7 is just minus 7. Okay, so this becomes positive, becomes negative. Oh, so once you have negative 3, negative 7, then you can proceed to combine those two, gave you negative 10. And 2.1, 8.4. So if you have done it many times like I did, you just realize that 8.4 is 4 times 2.1. So this is just 1 over 4. Or you can write it as 0.25. But once we get 0 to 0.25 and 10 to the negative power negative 10, this is not this decimal place should be moved to the right of the 2. So this creates another extra 10. So here you should have 2.5 times 10 to the negative 1. So you have negative 1 here, negative 10 here. So together give you negative 1, negative 10, give you negative 11. So 2.5 times 10 to the negative 11. Okay, so this is how the example works. Anyone has any question? Okay, so let's do A. And after we do A, I'll give you 3 minutes to do B. So 9/3. First, group everything together. So 9/3, there's the same type of number. So that can be grouped together. And those powers should be grouped together. So on this side, inside of this process, just get 3. 7 is easy. On this side, you have 10 to the 12 minus, okay, realize that you are dividing by 10 to the 4. So you're subtracting 4. So 12 minus 4 give you 3 times 10 to the 8. That's it. So does anyone have any question on this one? Okay, so I'll give you 3 minutes to do this. Remember, everything is exactly the same as we did here. Okay, just group all the numbers together, move powers together. If you get something decimal, try to move the decimal point. So 3 minutes to do it. Three minutes to do B. Not to B. Apologize. Okay, 3 minutes is over. So let's look at B. Again, very, very similar. Group the same type of numbers together. Then finish the division. So 3.2 divided by 2 is 1.6. And 10 to the 5 divided by 10 to the 4. Here's tricky. Dividing by another power is just subtracting the power of the other power. But since we have the power -4, so you are subtracting -4, which is subtracting -4. Subtracting -4. Okay, so make sure you have 2 minus sign here. So minus minus give you plus. Together you have 10 to the 5 plus 4, which 10 to the 9. That's it. Anyone has any question on this? So we are done with the second page. Now we turn to the third page. Give a meaning to numbers. For every number, we denote something, we represent something, right? Here it says, we will look at 3 techniques: estimation, comparison, scaling. So we are trying to use those techniques to get a more understanding on what does a number really mean. Okay, so we're trying to interpret the numbers here by using those 3 techniques. Do not memorize the names for the techniques. We will do some practice and you will know what I'm talking about when I mention estimation, comparison, and scaling. Okay, so do not memorize it. Examples will tell you everything. Okay. An order of magnitude estimate. So that's the first technique. We're trying to use estimation. Specifies a broad range of values, usually within 1 or 2 powers of 10, such as in the 10,000s in the millions. Those language may still sound very vague to you. At least it sounds very vague to me. So the whole idea is just try to use some words like sounds, meanings, or meanings. Just use those words to give the reader or give the listener a better understanding. Let me write down. Just use, the idea is just use words like sounds, meanings, meanings. Just use words like this. You will be done with the problem. First question. The US population is about 313.9 million people. And I tell you, this is outdated. So the US population is much more than that right now. So does anyone know how much the US population is right now? Do not Google, just guess. If you, let's see who has the best.
333 million.
Oh my gosh, 333 million? So that's your guess, or did you check on Google?
That's my guess.
Okay, so feel free to type in the chat, guess how many people are there in the US. Please do not Google. And I'm just trying to make this class a little bit more interactive. Do not use Google. Let you know, do not use Google, just guess. You guys are so good at guessing. So I share my screen. You guys see my screen? You guys so good at guessing. Exactly 333.331343. I don't know why we have so many threes on the US population. I think it's just coincidence. So very good. So you guys guess it very accurately. So let's continue. So this is outdated, but we roughly can say that the US population is on the order of 300 million. So that's so-called estimation. Okay, so here we have precise number. Now we have some kind of vague number. That's it. That's the whole point of estimation, making a precise number into a vague number. Let me write this funny sentence down. Making precise number vague. The world's population is estimated to be 3,725800000, so many people. So we know the first comma here is a sound. The second comma is a meaning. The third comma represents a meaning. Oh, so here we have how many people? 7 billion people, right? First common sound, second common meaning, third common meaning. So 7 billion people. Since we are just using some kind of vague number, so it is on the order of 7 billion people in the world. That's it. Sorry, my handwriting is kind of not well organized here. Let me read this again. On the order of 7 billion people in the world. So anyone has any question how I get it from here to here, here to here? Okay. So the number of times you blink your eyelids in a day, that's Sapiens or not. So how many people? So we first need to check how many times a person blink eye in a day. So feel free to type in the chat how many times you blink your eye. Let's say in a minute. Okay, let's first do a minute. You type in the chat. I type in my chat. I blink approximately 40 times. So feel free to type your answer. In a minute, how many times do you blink your eye in a minute? Okay, good. So let's look at the answer. Please look at the chat session. So we have somebody who just blink 10 times in a minute, and we have sometimes blink 100 times in a minute. So those are extreme values. But if you look at it, it seems on average, a person blink like around 50 is kind of the mean or the middle. Okay, so let's say just on average, a person blink 5 times a minute. So we need to convert 5 times a minute into how many times per day. So we know each hour has 60 minutes. And each day has 24 hours. So that's how many times you do it a day. Can anyone do me a favor? What this number is? Plug into your calculator to see what this number is. Feel free to tell me, speak out, or type in the chat. Okay, great. Thank Kidist for giving us the answer. So it is 72,000 times. So you blink 72,000 times a day. You can say that, again, just copy the same word on the order of the number of times you blink your eyelids in a day on the order of 72. We have 3 zeros, 72,000. 70. So we just keep one digit since we will try to make it vague. 70,000. That's it. So that's it for this question. Does anyone have any question? Feel free to speak out if you have any question. So we have 3 techniques: estimation, comparisons, and scaling. Once we are done with estimation, so this is just estimation, we should understand how big the number is through comparison. Making comparison can give meaning to the numbers. For example, we want to know how big is the US population compared with the world population. By the way, so just an interesting fact. This is just an interesting fact. This is not related with the class material today. US is the third largest country in the world in terms of population. Okay, just to let you aware, the US is third largest country in the world in terms of population. The first two are China and India, then it comes US. So we want to compare how big is the US population to the world population. How do we compare? We just do a division. We divide the US population with the world population. You can see US population is 3 to the 8. So it was 300 million, so it's 3 to the 8. And notice that we have two tildes here. So this means all the calculations are approximately. And the world has approximately 7 billion people. So if you do such a division, 3 over 7, 10 to the 8, 10 to the 9, give you 10 to the negative 1. This would make approximately 0.043. So the US population is approximately 4.3 of the world's population. That's it. So this is an example for comparison. Okay, so let's turn to do an exercise. This time, we're not comparing population. We are comparing US energy consumption. So by the way, a few days ago, President Biden was in Colorado talking about green energy. So the whole idea is that we should reduce the fossil fuels to prevent the climate change. So we also want to reduce the overall energy consumption. So now we should figure out, are we consume too much energy compared with the world's energy consumption? Notice that US is only about 4% of the world's population. So we can do a calculation to figure out how much energy do we use. Remember, we are only 0.04%, 0.043, which is 4.3% of the world's population. So we are curious, are we spending too much energy? Are we driving too much? Are we turn on the lights too often when it is not necessary? So again, we do a division. First, look at this table. So where is the US population? Or where is the US energy consumption? Here it is. It is here. So it is 1 times 10 to the 20. Whereas the world's energy consumption is 5 times 10 to the 20. So I'm not going to do the calculation for right now for you. I think you can spend 1 minute to figure out by yourself. Since this calculation is pretty easy, spend 1 minute to do the calculation by yourself. So if you figure out the answer already, please feel free to shout out to me or type in the chat. Great, I see somebody type in the decimal point. So can anybody convert that into the percentage? Very good, thank you, Dasha. And thank you, Elizabeth. Thank you, Kidist. So which is 0.2, which is approximately 20%. So here we need a moment of reflection. So we, the US, we only have 4% of the US of the world population. However, we spend 20% of world's energy. So definitely the 4% of people are spending too much energy. The 4% of people are spending 20% of energy. On average, we are 5 times. So per person, we are 5 times the average. I should write a complete sentence, apologize. The US energy consumption. Per person, US energy per person is 5 times the average. So please drive less. Please turn off the light when it is not necessary. Okay, anyone has any question on this one? Okay, so here comes our last question today. Perspective through scanning. Our third general technique, giving the meaning to numbers, use scanning or scale models. So if you look at a map, 1 centimeter is often just 1 kilogram, a kilometer. So look at this map. If on the map, you see just 1 centimeter, it is actually represent 1 kilometer in the real world. By the way, 1 kilometer is more than half a mile. So just help you understand a little bit. So this is 1 mile. 1 mile is 1.6 kilometer. So 1 mile is approximately that long. Okay, so this is scanning. Everything on the map is kind of shrinked. Originally, it's 1 kilometer. In the real world, we shrink to 1 centimeter on the map. That's just the idea here. So this is our third technique. And previously I typed in the chart thinking about your ideal salary. So here we have a case study. How many people can you employ with $1 billion per year? So everybody, please type in your ideal salary. I find the average, and I will find the average salary here to do the calculation. I will type my ideal salary first. Please type in your ideal salary also. This is mine. Hey, type in your ideal salary, and then we can finish this calculation. Hey, Yash, I like your creativity. Okay. If you have not typed in, please type in so that I can get an idea. Okay, so I see our class is very greedy. And it seems that Yash is the most greedy person. He wants infinity. I just want I saw in the training, he wants infinity. So he's more greedy than me. But on the average, let's get rid of those weird people like me and Yash. So on average, I think people want 200,000 a year. This is comma. This is not decimal point, please. Okay, so how many people can you employ with $1 billion per year? So 1 billion is 1, comma 000, comma 000, comma 000 divided by, on average, our class want 200,000 a year, just on average. So divided by this number. So now you can cancel those zeros. So you have 5 zeros here, and here you have 9 zeros. So you have 1/2, 10 to the 9. On the bottom, you have 10 to the 5th. So this is 0.5 times 10 to the 4th power. So 10 to the 4th power is, and you have is 10,000. So this is 5 times 10 to the 3rd power, which is 5,000. Okay, so let me make a quick conclusion. With $1 billion, you can hire 5,000 students in our class. Okay, thank you very much. That's the end of the calculation. So does anyone has any question before we leave? Do not go, let me take the attendance. Do not go. So, okay, I'm done with attendance. So feel free to go. If you have any question, feel free to stay here, ask me.
Thank you.
Thank you.
Have a good night.
You too. Hey, kiddies, is anything I can help you?
Yeah, I just have a question about the exam.
Yeah.
Is it gonna be in class or is it gonna be like at home online?
I have not seen the exam yet. I'm not the one who make the exam. So I will look at it and maybe tell you on the next class.
Okay, thank you.
Okay, thank you. Hey, Daniel, is there anything I can help you? Hey, Daniel, is there anything I can help you? Okay, seems like you're not there.